what's happening here with this screen, why on earth it looks purple, but we'll just do our absolute best with it, and I'll get it turned off as quickly as possible because that's hard for me to look at, as I'm sure it is hard for you. Okay, all right, the first two blanks, synthetic division. So we've done long division, and now we're going to learn a new technique that's called synthetic division. Synthetic division simplifies long division process for dividing by x minus a number. We're going to call it x minus a. So this only works in this case. It does not work if it's like 2x plus 1, 3x minus 5. You can't have a number in front of the x. You have to go to long division for those.
Never mind.
All right, to use synthetic division, you're going to write the coefficients, including any missing placeholders. We're going to need to put a 0. So underline this, where it says including zeros of the polynomial in standard form. You omit all variables and exponents for the divisor. Okay, the divisor, underline this, reverse the sign. This allows you to add the opposite instead of subtracting. So, for example, if you divide by x plus 3, so that's my divisor, you would use negative 3. It's the opposite of the divisor. So watch this. The first couple, you'll be sitting there scratching your head going, what on earth is she doing? And I want you to kind of take a deep breath and say, I'm going to wait, because she said this is going to be simple. Okay? Yeah.
Wait, so does this work for like x plus 3 or like x plus a number?
It works for x plus a number or x minus a number, but it does not work for a number times x, and it doesn't work for x squareds or dividing by x cubes, okay? So it only works in certain cases, but when you get the hang of this, it's really simple. So watch this. And again, I need you to just sort of stay with me because this is going to be very, very strange at first. So I'm dividing by x minus 7. So I put positive 7 down, and we're going to use a partial box, okay? So just, again, this will be really weird, but stay with me. And then you'll be like, oh, this is so easy. So you're going to put a partial box, and then watch this. In this row, I'm going to put a 1, a 0, a negative 57, and a positive 56 in the row with this 7. So I want you to write it down, and I want you to look at it. Do you see why I put the 0 here? What's that 0 from?
Because there's no x squared.
Awesome, guys. There's no x squared, so I need a placeholder for it. Okay. So the 1, the 0, the negative 57, and the positive 56. You omit all variables, and you just list the coefficients, okay? Now, we're going to leave a row for numbers, okay? Leave a row for numbers, and I want you to draw a big line here, but there's a space for your numbers, and then we're going to put a partial box underneath the very last number. And again, this won't make any sense until we do a couple of these, then I'll go back and explain it, but just sort of stay with me for now. All right, so here's how you do synthetic division. So you take the opposite of the divisor number, and it goes in this partial box. You list the coefficients of the polynomial, including any zeros. Now watch this. Nothing goes in the space underneath your first number, but underneath it, underneath the line, you just bring that number down. That works every time. Now watch this. You take the number in the box times the number under the line, so 7 times 1, and it goes in the second column. And then I add 0 plus 7 is 7, and repeat. 7 times this 7 down below the line, so you're always doing it to the line below. 7 times 7 is 49, add the column. So that's what, negative 8? And repeat. 7 times negative 8 is negative 56, add the column. What goes in the partial box at the end, this is your remainder. So this means there's a remainder of 0. Now I want you to stop and think. If I take the leading term divided by the leading term, x cubed divided by x, my answer is an x squared. So watch this. My answer is x squared plus 7x minus 8 with no remainder, because the remainder is 0. This is way easier than that big long division. The bummer is long division doesn't, or synthetic division doesn't work all the time, so we do have to use long division some of the time. All right, so let's try another one before you ask me any questions or say you don't get it, because right now it's new, so it shouldn't make much sense. All right, so what number is going to go in the box? Awesome. Okay, it's the opposite, so it goes -2, and then I'm going to list my coefficients. So that's going to go 1, I need a 0, -14, 51. Okay, and there I put a 0 because there's no x squared. You leave a space for some numbers, and we're going to draw a line, and you put a partial box under the last number, and that's going to represent our remainder when we're done. All right, so here we go. You bring the first number down, so there's nothing that goes underneath the first number above the line. And then we multiply and add. So, and because we're taking, and do you get it? The reason why I'm having you take the opposite of this is the opposite and add is subtraction. Okay, so we really are doing the division stuff where you multiply, subtract, multiply, subtract. We are doing it. So now we're going to take -2 times 1, and it goes in the next column. And then I add it. 0 plus -2 is -2. Repeat. -2 times -2 is +4. Add the column. -2 times -10 is +20. Add the column. So I do have a remainder this time. Now, how do you figure out what the exponent is? You can do it one of two ways. Either, if this is my remainder, this is the number, this is x, and that's x squared, and you go up from the remainder, that's one way to do it. Constant x, x squared, so if I had another one, it's x cubed. Or, you look at the leading terms. X cubed divided by x would be x squared. Either way you want to look at it. So here's my answer. X squared minus 2x minus 10, it's plus the remainder over the divisor. I like synthetic division. I find it very, very simple to do. All right, so if you're getting the hang of it now after a second one, I want you to try example 3. You should at least be able to set it up, so do as much of it as you can. And I'll pause and wait for you. All right, so I'm going to start it. I'm going to put -3 in the box. It's 1, 0, -10, -2, 4. Do you notice it's missing an x cubed? So I need a 0 in the x cubed position. Leave a space for numbers. And then I put a box underneath your last number. That's going to represent the remainder. All right, so you bring down the first number. Nothing happens to it. You just bring it down. Then I multiply. -3 times 1 is -3. Add the column. -3 times -3 is 9. Add the column. -3 times -1 is +3. Add the column. Negative 3 times 1 is negative 3, add the column. Now, you either take first term divided by first term to figure out the degree, or you go, this is the constant x squared, x cubed, whichever way you want to do it. So here's my answer. X cubed minus 3x squared minus x plus 1 over the divisor. All right, yeah.
Bigger than
Sure. All right, try example 4. Okay, if you're getting the hang of it, try example 4. If you're struggling, at least try to see if you can get it set up. All right, so this one's going to be positive 5 in the box. I go 3, negative 17, 15, negative 25. There was nothing missing. Do you see that? It went x cubed, x squared, x, and constant. So there was, and so remember, just like that homework problem I went over before we started the notes, if there's no constant, you do need a 0. You need a placeholder for the constant. All right, so let's try this one. I bring down the first number is 3. 5 times 3 is 15, add the column. That's negative 2. 5 times negative 2 is negative 10, add the column. 5 times 5 is 25, add the column. What does that 0 mean? No remainder. It also means x minus 5 is a factor. Okay, that means x minus 5 is a factor. So this is 3x squared minus 2x plus 5. Okay? It's not cubed. Why is it not cubed? Because you're taking an x cubed divided by an x would be an x squared when you're dividing. All right, when you're ready, flip it over, and I want you to try example 5 now. Let's see if you guys can do this one. I'm going to try this one. I'm going to put negative 2 in the box. I get 4, 8, negative 9, and negative 18. I bring down the first number. Negative 2 times 4 is negative 8, so that's 0. Negative 2 times 0 is 0, okay? Anything times 0 is 0. Add the column, that's negative 9. Negative 2 times negative 9 is positive 18. So this is weird. It's 4x squared. Now we're not going to leave 0x in our answer because 0x disappears. So that's 4x squared minus 9. And I want to pause here a moment. This is the answer. But what if I said to you, like I can make a little twist here and say, use synthetic division to completely factor the polynomial. So watch this. That means x plus 2 times 4x squared minus 9 multiplies to the 4x cubed plus 8x squared minus 9x minus 18. Do we know how to factor 4x squared minus 9? Yes, it's a difference of 2 squares. So if I wanted to factor it, I could completely factor. This is just if you wanted to, okay? So it's kind of a neat feature of something you can do. All right, the remainder theorem. The last topic here. The remainder theorem says this. If you take a polynomial, and we're going to call it P of x, and if you divide by x minus a, then the remainder, and this is really interesting, the remainder is P of a, so it's going to be the opposite of that sign. So watch this. If I divide P of x by x minus 1, so let's do that. We're going to put 1 in the box, and we're going to do 3, 1, and negative 5. Okay, and I'm going to show you this doing it a second way, and you're like, oh my gosh. Because synthetic division, would you guys say it's pretty simple? You know, like once you get the hang of it, it's like not bad at all. So I bring down the first number. 1 times 3 is 3, add the column. 1 times 4 is 4, add the column. Okay? Now I don't want the answer, but I'm trying to find P of 1. Watch this. Do you remember if I plug in P of 1 into this equation, that's 3 times 1 squared plus 1 minus 5. Well, 1 squared is 1. That's 3 plus 1 minus 5. 4 minus 5 is negative 1. Here's what this is like. Whoa, can you see this? P of 1 is equal to the remainder if you divide it by x minus the opposite of a, okay? Isn't that interesting? That's just like, okay, let me show you this. When we did the division, okay, the remainder is the same thing as if whatever went in the box, you directly substituted, which you did back in Algebra 1 and we did at the beginning of our year. If I plug in 1, the opposite of negative 1, it gives me negative 1, and that's my remainder. That's just interesting, okay? So let's look at example 7. It says, use the remainder theorem and synthetic division to answer the following questions. If you have P of x, and it has a remainder of P of negative 4, what was the factor I divided by? Look back up in example 6, do you remember? If I divided by x minus 1, it was P of 1. So if I have P of negative 4, what were we dividing by? Jesse, you know? X plus 4. Good job. Okay, so it is the opposite. Okay, it's always the opposite number. All right, so you were dividing by x plus 4, so let's do that. We're going to do the division, so it really is negative 4, and we're going to go 1, negative 3, negative 28, there's no x squared, so I need a 0, a 5, and a 20. I'm going to pause. And I want you to do the synthetic division. And the remainder is going to be P of negative 4. Like that is the answer. So are you getting a remainder of 0? Okay, so what that means, P of negative 4, okay, it's the opposite of this number, is the same thing as the remainder. Yeah.
Should I go? No. Still go where I'm supposed to go.
Yes, you have the notes, right?
Yeah.
I mean the homework?
Yeah.